Okay, guys, so here's me going over our first big quiz or quest of the year, which was Cycle A. So use the graph to find the indicated values and explain your answers to parts G and H. So here I'm being asked for just the function value at 2. Right, so I find 2. It's going to be the closed circle that's above it, so it's 3. Okay? And now I want the limit as x approaches 2 from the left. So if x is approaching 2 from the left, I'm going to be like over here. So like, yeah, so x is approaching 2 from the left. So as my x values get closer and closer to 2, I'm using this part of the graph. And as my x coordinates get closer and closer to 2, my y coordinates are staying right at 3. So we get that they're approaching 3. It's the same thing, even though it's kind of just staying there, or it is just staying there. All right, now x is approaching 2 from the right. So this time I'm thinking of x values over here, like from the left, for this one, it'd be like 1.9, 1.99, 1.999. Over here, so I'm approaching 2 from the right, it'd be like 2.1, 2.01, 2.001. So those x coordinates correspond to this part of the graph. And as the x values are getting closer to 2, the y values, so this sequence of points on the graph, those y values are getting closer to 2. F of negative 2 is right there, so it's 4. As x approaches negative 2 from the left, okay, so negative 2 from the left, those are values over here. So like it'd be like negative 2.1, negative 2.01, negative 2.001. And when you're plugging in those x values, you're on this part of the graph. You're on this part of the graph up here. And you'd be looking at this sequence of points, and their y values are getting closer to 4. Negative 2 from the right, so we're over here. So that'd be like negative 1.9, negative 1.99, negative 1.999. So it'd be this sequence of points, and the y values of those, as x approaches negative 2 from the right, these y values are getting closer to 4. Okay, now, how about just the regular limit? The limit as x approaches 2 of f of x, what is it? Well, up here, guys, in order for a limit to exist, the left-hand and the right-hand limit have to exist and they have to be equal. So when we saw up here for parts B and C, these are not the same. Okay, so the answer is does not exist, and I'll say because the limit as x approaches 2 from the, let me put the right first, but, all right, so these limits are not equal. So the overall limit does not exist. Now, how about this one? This limit, as x approaches negative 2, what is it? It is equal to 4. All right, and the reason, why is it? Well, this limit exists because these two limits equal each other. This limit equals 4 because these two limits equal each other and they equal 4. So I guess I'll say it like this. I'll be like, because the limit as x approaches negative 2 from the left is equal to 4, which is also equal to the limit as x approaches negative 2 from the right. Okay. Number 2, find the indicated values for the given piecewise function. And then we're going to explain our answer to part D. Okay, so f of 1. All right, so we're using this part for x is less than or equal to 1. We're using this part for x is greater than 1. So f of 1. So I'd be plugging into this top, and it'd be 2. The limit as x approaches 1 from the left. All right. So here I'm thinking of like 1 the whole time. So numbers to the left of 1 would be like, and I'll just write them here, would be like 0.9, 0.99, 0.999. And then to the right of 1 would be like 1.1, 1.01, 1.001, 1.001. All right, so I'm approaching 1 from the left, so I'm thinking of plugging in a sequence of numbers like this. So if I'm plugging in like these numbers, they'd be less than, or I'd be at this point. So I plug in 0.9. I'm pretty close to 2. 0.99, even closer to 2. 0.999, even closer to 2. So the limit is 2. And guys, we'll see this in later phases when I go over it. But if a function is continuous, which this whole function is not, but if you just look at this part here, since this part of the function is continuous, like on its own, you could think of just plugging in 1, because you're getting super close to it. So you could just plug in 1, I guess, and get 2. That would work, if it helps you to think of it that way. All right, now 1 from the right. 1 from the right, I'm plugging in numbers like this, so I'd be plugging into -3, which is a constant function, so it's just that. And then here, what about the overall limit? It does not exist. It's asking you to explain, because the limit as x approaches 1 from the left is not equal to the limit as x approaches 1 from the right. Okay. Evaluate the limit below. All right. So, yeah. So we're plugging in numbers to the right of 0. Yeah, and you know what, guys? Honestly, on the AP test, that's what we're getting ready for here. You could just use your calculator. So let me just show you something. All right, so we're approaching 0 from the right. All right, so 0, there's 0. All right, we're approaching 0 from the right. So those would be numbers like 0.1, 0.01, 0.0001. So you're going to have your calculator on the AP test. So I didn't teach this one to you like this, but we might as well. You plug in, so I'll plug in this input, which is 4x plus 3 over x. And then I'm going to go to the table. I'm going to make sure my table is on ask so that I can plug in the numbers I want. And I'll plug in 0.1, 0.01, 0.001. And see how big it's jumping, guys? It's going up really. The closer I get to 0 from the right, the bigger that this input function is getting. And the closer, I just keep adding more zeros, and it just keeps getting even bigger. Well, what am I doing? Even bigger. So guys, what's happening? If the y values are just getting bigger and bigger and bigger, this is going to positive infinity. All right. And alrighty, now down here, you're given a limit involving infinity. Use an arrow diagram to interpret the limit. Sketch the asymptotic behavior described by the limit. Label any asymptotes with their equations. All right. So here we've got, so as an arrow diagram, this is telling us that as x approaches -2 from the left, the y's are approaching infinity. So here's the sketch. All right, the x's are approaching -2 from the left. So here's -2. And I'm approaching from the left, my x's. And as my x's are approaching -2 from the left, the y values are shooting way, way, way up to positive infinity. So the asymptotic behavior that we have here is a vertical asymptote. And then you could just go like that. And then label any asymptotes with their equation. This is x equals -2 is that asymptote. All right, then we've got this one, arrow diagram. X is approaching -infinity, y is approaching 7. All right, so the sketch. As x is approaching -infinity, so I'm going further and further and further to the left. All right, so the x's are approaching negative infinity. The y values are approaching 7. So you're going to do, so y equals 7 is the horizontal asymptote. And then it'd be something like that. And you could come at it from above as well. But here's the case where as my x's are getting big in a negative direction, my y values are leveling off at 7. Okay. All right. Do not have to evaluate. Okay, I'll just say do not evaluate. Do not evaluate any limits for this problem. Of the limits below, which can be evaluated using the end behavior model and then explain. Guys, for the end behavior model, the limit needs to be going to positive or negative infinity, and you need to have a polynomial over a polynomial. So that would be A, D, and G. A, D, G, right? I think that's it. Explanation, because the limit is approaching infinity. It really could be positive or negative infinity, so I'll say positive or negative. Because the limit is approaching positive or negative infinity. Oh, and I'll just go, and we have a polynomial over a polynomial. All right. Now, that brings us to a bunch of problems where we're going to use the end behavior model. So evaluate the limits. Use proper limit notation throughout the problem. Guys, this is the situation that I just had. All right. We have a limit as approaching infinity, and we have a polynomial over a polynomial. So what you're allowed to do is that you can say that this is just equal to the limit as x approaches infinity. And then what's the highest power term up top? It's 4x to the 5th. The highest power term on the bottom, 2x to the 10th. And then you can simplify. All right, this ends up being 2 over x to the 5th. And you could, if you want, plug in the infinity. So that's going to be infinity to the 5th. Guys, 2 over a huge number. Okay, 2 over a huge number. If you forget, like, what that'll come out to be like 2 over 1,000. 2 over 10,000. All right, that's an even smaller number, so it's approaching 0. Okay, here's another end behavior model one. Okay, 2x to the 5th over x squared. 2x to the 3rd. 2 infinity to the 3rd. Guys, infinity to the 3rd, that's just a huge, that's just another infinity. It's another form of infinity. All right? Infinity is not a number. It's an idea of just getting bigger and bigger and bigger without end. You could treat it like a number the way I just did, but it is it's more of a concept. Alrighty, and behavior model again, because x is approaching infinity. 5x squared over x squared. This is a constant function. It doesn't matter what's happening to x. X could be whatever, and the function is always going to be 5. All right, so the limit of a constant is just that constant. Okay, so that's it.